In this final video, we're going to be looking at polymorphism. Now, polymorphism is a very complex part of OO, and it's something that's very difficult to get your head around. Thankfully, you don't have to be able to code this at all. You do need to know what it is and roughly how it works, but you're not going to be expected to be able to code it. Certainly not expected to be able to design code in order to take advantage of polymorphism. So let's dive into it. Polymorphism is the ability to represent an object as a different data type, or what we really mean in this case is as a different class. So in order for polymorphism to work, the original class and the polymorphic class must share a common interface, and we achieve this through inheritance. So you won't necessarily be able to understand polymorphism if you don't understand inheritance. So if you at this point don't understand inheritance, please stop. Go back to inheritance, get your head around that, then come back to polymorphism. Let's see an example. So here I've got a simple inheritance structure. Class foo is my parent class, and I've got three classes, A, B, and C, whom all inherit from class foo. This means that they all have access to the method bar. Okay, so class A has bar, class B has bar, class C has bar. However, each class A, B, and C also add their own methods, method A, method B, method C. Now, because they all inherit from class foo, they all have the method foo, the method bar. So we can treat class A as if it's a foo, because we know it has every single method. So let's see this in action. So I've got two objects, both of which I instantiate a class A and class B. So object 1 is class A, object 2 is class B. Now, object 1 can use the method A because it is a class A. Object 2 can use the method B because it is a class B, but both of these objects can use the bar method. Okay, because they both inherit from the same class. So all these method calls are perfectly acceptable. This means I could treat object 1 as if it's foo. Okay, so I can cast it to a foo class. So I can pretend object 1 is foo and object 2 is foo. This is polymorphism. Okay, so polymorphism is when I change the data type of one class into another. So object 1, instead of being a class A, I'm pretending it's actually a foo class. And object 2, instead of letting it be a class B, I'm pretending it's a foo class. Okay, but why on earth would I want to do that? It might seem a bit odd to do. Imagine I had an array of class A, B, and C. Okay, and it's all mixed up. So we've got a class A here, a B here, and then a C, then another A. It's all mixed up, higgledy-piggledy. But because they all share a common ancestor, they all have the foo class as their parents, and I know because of that they all have the method bar, I can iterate over that array and quite happily call the bar method. I know they've all got it. Okay, I'm confident in that. So even though we have three different classes, because they all inherit from the same class, they all have to access the same method. Okay, and this is the advantage of polymorphism. I'm treating them all as if they're foo classes. Okay, and I know because they're all foo classes, they all have that bar method. Okay, so this is the advantage of using polymorphism. I'm treating them as if they are their parent class, so I can just use the same method across all of them without having to worry about what class they are. So you're not expected to code polymorphism in the exam, but you are expected to know what it is. Do have a little bit more research on polymorphism, see how it's used. The more you see it, the more it makes sense.